Hello YouTube. I've gotten a little sidetracked from my motor here to start working on this optical tachometer. I'm hooking it up so that you can read the RPM of the motor a little bit better than this with this camera. This oscilloscope just doesn't show up, so you can't really tell how fast it's going. So I took my optical tachometer apart so that I could hardwire it into the circuit. I had to make a little bridge circuit and hook it up to the Hall sensor. Hall sensor is connected the same way it was. It's just this comes off onto another CMOS transistor, and then I take it through an opto-isolator to isolate it from the actual tachometer. I figure I'd play it safe that way. Anyhow, I hacked the tachometer by looking at this chip. It's the AT89C51, and I discovered, you can't probably tell, but pin 12 on this chip is interrupt 0, and that's where the pulsing comes from with the photodiode. So I simply cut the trace there on board and wired in directly where the rest, or where the signal would have come in normally into the microcontroller. So I'm going to tidy it up a little bit and continue the video. Okay, I'm back. I made a few changes here. I installed a double pull, double throw switch so that I could still use this as a meter, and conveniently underneath this circuit board there seems to be a little holder for a switch that would be similar to this, and there's a hole there too, so it makes me wonder if they didn't have that in mind. Anyhow, I soldered a couple of power lines, positive and negative, with some pins on them so that I can attach the circuit. Still a little crude. It'd be nice to have a connector, you know, you could connect and disconnect, but this will work. After I get done, I'll be able to close the lid and have the wires coming out, and now I'll tape them up or something, just to, if I want to use this as a optical tachometer. It still works because I put that switch in there. So I can switch between optical or having a digital input. So I click the switch on there and I get power. I still have an an LED glowing there, but I'm not too worried about that. I have a usable tachometer now. I'm just gonna fire up the motor here real quick, real low. I'll set it for about 6 volts or so, and turn it on, give it a spin. You'll see that it doesn't show a decimal point, but at least as far as I could tell there. But now it's reached over 1,000 RPM, and let's see if that meshes up with what's on the screen. I'm not even going to bother trying to focus on that because it just won't. If I do the math, though, it's reading 18 hertz. It looks like it's climbing still, and that's 1080, and we're showing about 1100, so they're pretty close. This will work out nice. I'm just going to put it back together, and I'll show you the final product when I'm done here. Okay, I'm back. I've got it all placed back together. Got the switch on the side. I actually planned on having the switch on the other side and the wires coming out the opposite. but as it turns out that the switch didn't mount the way I thought it was going to, so I used this side axis here and wired it up that way. But it's all working good now. Just wanted to show you the schematic if it'll actually show up well. There's the Hall sensor, and it comes out and it goes into the N channel, and there's the coils, and the back EMF goes through 4 diodes to a capacitor, and the signal from the Hall sensor also goes to this N channel here, which is driving this opto-isolator, which connects to that processor inside the DM6234P digital tachometer. You probably can't read that. So it's working, and it's pretty accurate, so I'm happy with it. That's it for now.